Good evening, everyone. My name is Mei, and I'd like to welcome you back to another Tech Talk in our series sponsored by Codesmith, Jeeny, and Bractlet. Today, we have the pleasure of welcoming our amazing Kyle Slugg to give us a brief talk about WebAssembly. So without further ado, I'd like to pass it over to you, Kyle.
Thanks so much, Mamie, for that generous introduction. And thanks, as always, to Codesmith, to Jeeny, and to Bractlet for their great sponsorship. Last but not least, thanks to all of you for being here this evening and for listening to this talk about WebAssembly, technology that I'm quite excited to present about. So I'm going to be running through first some basics on what WebAssembly is, but then perhaps with some greater emphasis on what the current and future applications of this technology are. So first, let's start off with the very basics. What at its core, at its most technological, is WebAssembly. Really, at its heart, WebAssembly is nothing more, nothing less than a very low-level language that is supported in the browser that's analogous to, and in fact resembles quite a bit, the assembly language used in desktop applications. That is to say that it's distributed in a very compact binary form as a set of instructions that run on really nearly any platform on a stack-based virtual machine. And just as an aside, when I say it's distributed in binary form, that's in contrast to something like JavaScript or Python that's distributed in the form of semantic instructions that are interpreted and then run directly. So WebAssembly does have a text form that resembles the binary instruction set, but it's very rarely used or manipulated directly. Instead, WebAssembly is primarily what's known as a compilation target for other higher level, high performance languages like Rust and C++, and increasingly for other languages, including a subset of TypeScript that I'll talk about briefly later on. One important thing to know is that WebAssembly has been developed for years as a standard by the World Wide Web Consortium, which makes it, in that sense, an official language of the web, alongside things like JavaScript, CSS, and HTML, supported by all major browsers. And, again, in that sense, it is essentially the standard way to deploy high-performance languages alongside other languages in the browser. You have probably heard that, and I am sure you are still thinking, but what is WebAssembly actually? What does it mean for me? And what, in practical terms, does it do? So, at the most simple, WebAssembly is a modular, secure, and extremely portable platform for processing heavy tasks in and outside of the browser. And that is because it essentially forms a wrapper for complex algorithms that turns them into stateless components that interoperate with other common components of the web. And in doing so, use very little overhead. Because of that, WebAssembly, if you lean into the performance aspects of it, really provides a path to widespread deployment of tech that requires substantial real-time processing. Things like VR, which I'm sure is on everyone's minds today, and automation. And if you lean a little more heavily into the portability side of it, it provides a route to really full feature web applications in smaller scale serverless or distributed environments. We'll talk about both of these in just a second. So at present, the main use case for WebAssembly is in what I'm terming here high performance web applications. So previously desktop applications that have been brought to the browser in nearly complete form. And one really good example of this is Adobe's Creative Suite software. So since 2020 or so, Adobe has been using WebAssembly to port its flagship products, things like Photoshop and Lightroom, to the browser. And as anyone who has previously used Adobe's browser tools knows, before WebAssembly, they were extremely limited in what they could do. And that's because the image rendering routines that are used for something like Photoshop are written in C++ and proved far too resource intensive to run as JavaScript, which meant that the editing capabilities in the browser were very limited, almost non-existent. And the creative tools that this software provides were, you can hardly say they were portable. They were very much limited to the desktop environment. Now, however, Adobe has used various transpilation tools to compile their desktop software to WebAssembly, and essentially brought most, or if not all, of the desktop features into the browser versions of these software, making them far more portable. And for what it's worth, these two platforms can actually now develop in tandem because it is so simple to transpile C++ into WebAssembly. A feature that is developed for one of these platforms can very easily be ported to the other. And I'm not going to go into them in detail, but other sort of examples of this are things like Google Earth, which has also used WebAssembly in their browser applications, and AutoCAD, which is the industry-leading computer-assisted design software used in fields like architecture and that sort of thing. The second use case that I'm going to talk about this evening for WebAssembly is not quite as common at this point in commercial applications. And that's because it's really developing alongside WebAssembly as a language. And that is processing in distributed environments, particularly intense processing in distributed environments for things like virtual reality and augmented reality, as well as the somewhat strangely named Internet of Things, which is to say connected devices ranging from vehicles to household appliances. These technologies all require, well, essentially real-time processing in whatever location they are in. They need to collect information from their environment, process it very quickly, and make decisions based upon it. And because WebAssembly is, by nature, very compact, this lets the applications that are processed in this form be positioned very close to the technologies they are being used in something like an edge environment. This means that a device, even if it's somewhat low powered and has to sort of send off for information, can get the information it needs and the processed information it needs with very low latency. On the other hand, because WebAssembly is so efficient in its execution, it actually makes it possible to perform onboard processing in settings where this previously was not possible due to limitations on computing power or memory. And as a result, whether processing is taking place remotely or aboard various devices, WebAssembly really facilitates the decision-making, whether that be human decision-making based on processed information or automated decision-making based on same, at the speed of human action. So if you're in a self-driving car, for example, you can dodge to avoid obstacles much as a human might. And as I say, this field of applications is somewhat underdeveloped, but it's rapidly advancing, and I'm very much looking forward in years to come to seeing how it moves. So as that might suggest, while the use of WebAssembly is expanding, there are still a number of challenges that need to be conquered before widespread deployment, or perhaps even wider spread deployment, is possible. As I referenced at the beginning, at this point, most WebAssembly is still compiled from existing high-performance languages like C++, like Rust. And that means that if you are developing in WebAssembly, you need, or for the most part, you need to know one of those high-performance languages or learn it. That, however, is changing. I'm not going to go into it in great detail tonight, but if anyone is interested in exploring this, I highly recommend you check out something called AssemblyScript. It's a subset of TypeScript that compiles to WebAssembly. And as you might imagine, it doesn't include the full feature set available in JavaScript, but quite a bit of the functionality that you are used to is now available through AssemblyScript to be compiled into WebAssembly. And it's of great interest to me, and I suggest you take a look into it. In addition, the set of tooling around access to like the most common web browser APIs is fairly limited in WebAssembly. At this point, WebAssembly modules can't directly manipulate the DOM, for example, and need to rely on JavaScript wrappers to do that for them. This is gradually changing as well. It remains to be seen exactly how far we can push this in the years to come, but exciting developments are afoot. Lastly, there are quite a number of deployment-related tools for WebAssembly out there. So runtimes, transpilers from other languages, etc. But there has yet to emerge real standards in this area. It's sort of a free-for-all as far as what technologies are most suited to what applications. So look for this to shake out a little more for consensus to build around a couple of different tools in the years to come. All that aside, I do want to end on sort of a hopeful note and say that I am fairly confident, and it seems like consensus is emerging, that WebAssembly may at one point supplant similar wrapper technologies that exist today. Things like virtual machines that gradually gave way to containers that now appear to be giving way to WebAssembly modules. So, I invite you to sort of dig deeper into this technology as it really might become in the years to come, a standard that unites both in-browser and out-browser applications. Yes, and that is the introduction. So I think we have a little bit of time to take questions, and I would love to, but before we get to that, just want to say, if you want to keep discussing this or any other topic, please do reach out. I love to talk about this stuff. You can find me on LinkedIn at Kyle Slugg or at kyleslugg.com. So Maymay, if it's fine by you, I would love to open the floor to questions.
Yes, sure.
Also, I might need you to alert me because I cannot see hands.
Does anyone have any questions for Kyle? Nick?
What are some other software or technologies you've come across that use WebAssembly besides the Adobe Creative Suite?
So actually, Zoom is building out their in-browser functionality, and that sort of combines the processing advantages that I mentioned with the close to the user deployment. As I understand it, and fact check this before you quote this, but I believe it's the case that Zoom is sort of partnering with an edge platform to deploy those modules close to the user in the browser and facilitate real-time image processing within the browser rather than just on the desktop. So that sort of application is, I think, representative of where WebAssembly is going today.
Oh, I think we have time for one more question. Ron?
Hi, I was wondering if you looked into a web GPU and how does WebAssembly kind of relate to that, and does it relate to its development at all?
That's a good question. I can't speak on that authoritatively. My sense is that the two work in tandem to some degree. I know there are extensions to WebAssembly that are being developed that would interact directly with GPL, something. But I can't speak in detail about that. Yeah, as I say, I sense that they are related. I believe that there is some attempt to merge them, but that's sort of outside of my area of expertise.
Gotcha, thank you.
I think that's all the time we have for questions, right, Kyle?
All right, thanks so much. And maybe I'll hand it back to you.
Thanks for that informative talk, Kyle. And thank you everyone for joining us tonight. We will see you at the next one.